This is a breadboard, and this is a breadboard. With this one, you have to solder the connections to make the circuit work. But this is the one I want to cover today because you use it for prototyping. You test and experiment on your circuits before you install them. That's kind of the advantage, and you don't have to solder anything. To understand breadboards, there's just a few of the basics that you need to know to help you get going. Inside these fancy plastic blocks are alloy spring clips, which hold the wires and components in place. The blue and red vertical lines on the sides are called your power rails. When you plug your power into the hole, that voltage is present all the way up and down that power rail. The center of the breadboard is divided into two columns of terminal strips, which are separated by the channel. The channel is important because it is perfectly spaced for IC chips so that signals can be independently tied in on the left and right of that chip. To make all these connections, you can use DuPont jumper wires, flat jumper wires, or mock-up wire. Now that we covered the basics, let's have a little fun. I want to light up 4 LEDs for a prop I'm working on. For this round, let's not get worked up about Ohm's law. Let's just accept that for an LED to work, you need a power source and you need a resistor. To ensure the current doesn't blow up the LED like Alderaan being powered up by the Death Star, a resistor is needed to restrict the current flow. Maybe if there was more resistance fighters, some things might not have happened. So we will need power by way of a 9-volt battery, 1K ohm resistors, and 5mm LEDs. Now it doesn't matter which side of the LED leg the resistor is on, but for our purposes today, I will place the resistors from the positive power rail to the terminal strip, each on their own row. Now let's move to the LED placement. It's super important to remember that LEDs are diodes because they strictly observe polarity, which means power can only go in one direction. So the anode, or positive leg of the LED, must connect to the positive side of the battery. The positive side is the long leg of the LED, which we will place in the same terminal strip row as the resistor. Now, we will use a flat jumper wire to connect the negative leg of the LED to the negative power rail, which is blue in this example. Now, to complete this circuit, we need to add the power from the 9-volt battery. You connect the negative from the battery to the negative power rail, which is blue. And the final step is to connect the positive side of the 9-volt battery to the positive power rail, which in this case is red. There, now we have light. Let's see how this looks in our prop. If you like this content and want to see more, click the links at the end of this video.